So today we are going to start with S block elements, that is group 1 and group 2 of periodic table. The elements of hello.
सर वो लास्ट टाइम आपने स्कूल में हम होमवर्क दिए थे ना, उसका थर्ड वाला नहीं आया।
Okay. Group 1, group 2 elements or S block elements is what we are going to study. So this group 1 consists of starts with hydrogen, which is not properly considered of, is not considered only of this group. Rather, hydrogen is there between group 1 and group 17. However, we will just write a few basic things about hydrogen over here, and then we will move on. The next element of this series is lithium, followed by sodium, followed by potassium, followed by rubidium and cesium. I'll give इसको हॉरिजॉन्टल लिख लेते हैं rather than vertical. So group 1 will have these elements: hydrogen, lithium, sodium, potassium, rubidium and cesium. Now some of the basic properties like atomic number for them is 1, 3, 11, 19, 37, 55, francium, that is 87. General half-life of, and this is a radioactive element. Radioactive with half-life 21 minutes. Next information about them is atomic radius. For hydrogen it is 0.208 nanometer, which is also equal to 20.8 picometer. Post atomic radius we have ionic radius. यहाँ पर primarily I'll be comparing cationic radius. Yeah. Cation radius. and then hydrated cation. Hydrated cation radius. ठीक है? Okay, for hydrogen, the cationic radius is going to be very small because it has just one electron. If that one electron is gone, you are left out with just nucleus whose size is very much negligible compared to the size of atom itself. Is it okay? So ये picometer से basically फर्मी मीटर FM10 to the power -15 के रेंज में चला जाएगा. So we just ignore it. It's almost zero. For lithium, the value is cationic radius is 60 picometer. ये क्या होगा? ये फर्मी मीटर में होगा. Fluke FM. Is it okay? And if we are going to believe Rutherford, its value will be 1.33 Fermi meter. ठीक है? Sodium के लिए the value is going to be 95 picometer PM. Then for potassium the value is 133 PM. For rubidium it is going to be 148 PM. And for cesium it is going to be 167 PM. Hydrated cation radius for these elements are 340. Sorry, not for this. For this it is 340 PM, followed by sodium for which it is 276 PM, followed by potassium which is 232 PM. For rubidium it is 228 PM. For cesium it is 227 PM. The next piece of information regarding them is their respective ionization energy. For hydrogen we know that it is 13.6 electron volts. ठीक है? For lithium it is 5.4 electron volts. For sodium it is 5.1 eV, 4.3 eV, 4.2 eV and 3.9 eV. ठीक है? So all the trends are pretty much clear. Atomic radius increases down the group. Cationic radius again increases down the group. Hydrated cation radius, cationic radius, that is decreasing down the group. ठीक है? Cationic, atomic, ये दोनों radii increasing down the group. Hydrated cation size that decreases down the group. ऊपर से नीचे decrease हो रहा है. ठीक है? Not increasing. Why? Because size, as the size of cation increases, charge same रहता है. Charge by radius ratio decreases down the group, and therefore their tendency to pull or attract H2O molecule will definitely decrease, right? एक पॉजिटिव चार्ज इतने कम में कन्फाइंड हो और एक पॉजिटिव चार्ज इतने बड़े में हो और दोनों के पास इस तरह से नेगेटिव जो है delta negative I, where can we expect the attraction to be stronger? In the first case or in the second case? Obviously, it is going to be the first case where the attractions are going to be greater, right?
Yes, sir.
And therefore, there is more of H2O molecules which binds itself to the cation, to the smaller cation, and greater level of secondary bondings. ठीक है? Uh, Basically solvation के through the secondary bonding which is formed. Uh, so should I call the secondary bonding between the cation and the uh, negative polar end of H2O molecule. Uh, the extent of bonding with lithium is going to be much greater because of uh, charge, greater charge by radius, charge by radius, charge upon radius ratio. ratio. So lithium has this ratio, greater ratio, and therefore it will have a greater binding capacity. Okay. Uh, then we have ionization energy trained. Ionization energy for hydrogen 13.6 electron volt, quite high, but for rest of the elements lithium onwards it's significantly lower. 5.4 electron volt, 5.1 electron volt, 4.3, 4.2, 3.9. These are the lowest values across the period. The first group has lowest ionization energy, uh, hydrated radius and all का फिर अलग से I'll be doing for group 2 elements also, so we'll see that those values as well. You have noted this information.
Yes, sir.
Our next thing is elements of group 2. Beryllium, magnesium, calcium, strontium, barium, radon, 4, 12, 20, 38, 56, 88. Atomic number. Atomic radius 112 picometer, 160 picometer, 197 picometer, 215, barium it's 220 pm. Approximately 227 picometer. Then we have ionic radius, and in fact it's catanic radius. Catanic radius. This is 31 picometer, 65 picometer, 99 picometer, 113 pm, 135 pm, and 140 pm. सी यहाँ पर एक छोटी सी इंफॉर्मेशन, I mean the exact value of hydrated cation ratio is not available, nor does ionization energy, but they are not very relevant as well. See, beryllium, magnesium, calcium, strontium, barium and radium, इनका दो आयनाइजेशन एनर्जी होगा, 1 and 2, ठीक है। वन आयनाइजेशन एनर्जी 1 का ट्रेंड जो होता है दैट इज गोइंग टू बी obviously decreasing down the group ionization energy. There is no funny business in this. So ionization energy 1 and ionization energy 2 दोनों का ट्रेंड डाउन द ग्रुप जो होगा दैट इज गोइंग टू बी डिक्रीजिंग its values. Ionization energy 1 value is going to be greater than ionization energy value of group 1 element, ठीक है। ionization energy 1 of group 2 element, ionization energy 1 of group 2 element IE1 and then IE2. So IE1 is going to be greater than IE1 of group 1 element, ठीक है। इसका 5.4 है तो इसका 5.4 से ज्यादा होगा। वैल्यू एग्जैक्टली क्या होगी, दैट वैल्यू इज नॉट रिटेन एनीवेयर, not very precise values are available anywhere, or I could not locate it at least, so I haven't given it as of now. Uh, Maybe I'll try to find it out again today and will give it to you. But as of now, that ionization energy and second one is hydrated cation radii, that is not available. ये वाला जरूर मैं निकाल करके दूंगा, हाइड्रेटेड कटायन कैटायनिक रेडियाई, ठीक है। और यहाँ पर भी हम रेडियस, यहाँ पर भी हमको ये देखने के लिए मिलेगा क्योंकि चार्ज बाई radius ratio for beryllium, magnesium, calcium, they are all greater than charge by radius ratio of lithium, sodium, potassium. तो ये हाइड्रेटेड कैटायनिक रेडियस जो है ना, वो या तो ये वैल्यू होगा या इससे बड़ा वैल्यू हो जाएगा। 340 अगर लिथियम है, लिथियम प्लस का है, तो बेरिलियम 2 प्लस जो है दैट इज गोइंग टू हैव ग्रेटर हाइड्रेशन, ठीक है। एक्सटेंट ऑफ हाइड्रेशन जो होगा दैट विल बी ग्रेटर देन लिथियम प्लस। सिमिलरली सोडियम प्लस से ज्यादा मैग्नीशियम 2 प्लस का हाइड्रेटेड कैटायनिक रेडियस रहेगा, ठीक है। दैट इज व्हाट वी आर एक्सपेक्टिंग and we'll see that the values are going to be coherent with it. I don't have that value as of now, but I'll definitely get it today and will let you know. I mean, I'll fill up this data and let you know in the next lecture, ठीक है। This will be helpful. This information is going to be helpful in order to ट्रेंड हमने periodic properties, periodic classification में देख रखा है। ये जस्ट उन वैल्यूज को आई मीन उस ट्रेंड को असर्टेन करने के लिए वैल्यूज मैंने दे दिया है। दिस माइट बी हेल्पफुल इन एक्सप्लेनिंग सम ऑफ द प्रॉपर्टीज क्लोजली, ठीक है। नेक्स्ट इंफॉर्मेशन अबाउट एक और इंफॉर्मेशन which I would like to give, ठीक है। just a minute. ग्रुप वन के रेस्पेक्ट में भी, और ये नोट करना होगा तुम्हें. Turn page and form those informations. So we'll have to note that. That is hydration energy. Hydration energy. And the second one, and second information is flame color. Third one is oxidation potential. ठीक है. So hydrogen के लिए these informations are not relevant, but from lithium it becomes relevant. Lithium के लिए the value is 506 kg per mole. For sodium it is 406 kg per mole. 330 kg per mole. 310 kg per mole. 276 kilojoule per mole. Flame color is crimson red, golden yellow, pale violet, this is violet, this is blue. Oxidation potentials are plus 3.05 volt, plus 2.71 volt, 2.925 volt, plus 2.93 volt, plus 2.927, approximately 2.3 volt only. So oxidation potential down the group, kind of from here to here it is constant. यहाँ से ये कम हुआ, उसके बाद ये almost same है. For this beryllium magnesium के लिए the ionization energy is hello.
And
The ionization energy value for this is also available. Sorry, it's 9.2 electron volt, 9.32 eV, 7.64 eV, 6.11 eV, 5.7 eV, 5.2 eV, 5.3 eV. Hydration energy is hydration energy is 570 kilocalorie per mole. Kilocalorie per mole. 460, 395, 355, 305. So this shows that group 2 elements are more hydrated than group 1 element. Okay? They are more hydrated than group 1 element. Second group K elements, all the elements are having respectively greater hydration energy. That means they are more hydrated, and that is also expected based on their charge upon radius ratio. Okay? Which is greater than group 1 element, and therefore definitely their hydration energy has to be greater than their uh, hydration energy had to be greater than group 1 elements for them. Then we have flame color. Flame color is uh, there is no color for beryllium and magnesium. We don't get any color. No color. Uh, for calcium we have brick red, followed by strontium which is crimson red, followed by barium which is green in color, which has green flame color. Radium it is uh, just crimson yellowish color. And the ठीक है. Oxidation potential for them is oxidation potential 1.85. This is in volt. For this it is 2.37, 2.87, 2.89, 2.90. ऑक्सीडेशन पोटेंशियल का मतलब क्या है? How easily can it lose its electron? Oxidation potential का मतलब amount of voltage produced. If I'm going to put metal ion मेटल एंड मेटल आयन इलेक्ट्रॉन यानी इलेक्ट्रोड, दैट इज लाइक एक सॉल्यूशन जिसमें मेटल आयंस रखते हैं हम, जो भी मेटल है, जैसे कैल्शियम है तो कैल्शियम 2+, और यहाँ पर कैल्शियम का रॉड अगर डिप करके रखते हैं तो इन दोनों के बीच में जो पोटेंशियल डिफरेंस रहेगा, that is this potential difference, and this potential difference is increasing down the group. It is easier to oxidize. Oxidation potential जितना ज़्यादा, इसका मतलब it is easier to oxidize that particular metal. यानी सबसे कम बेरिलियम क्या है, तो बेरिलियम को ऑक्सीडाइज करने में हमको सबसे ज़्यादा डिफिकल्टी होएगी इन सब में। और अब ऑब्वियसली ये बिहेवियर जो होता है रिलेटिव बिहेवियर होता है, इफ आई एम कंपेयरिंग इन द ग्रुप इट इज मोस्ट डिफिकल्ट टू गेट ऑक्सीडाइज। अगर हम पीरियड में देखेंगे तो सक्सेसिव एलिमेंट्स आफ्टर दिस, जैसे बोरॉन, कार्बन, नाइट्रोजन, दीज आर मोर they are less prone to get oxidized and their oxidation potential is going to be lower compared to this। ठीक है, 1.85 इवन हम यहाँ के बेसिस पर कंपेयर करें तो हमारा ऑक्सीडेशन पोटेंशियल जो है प्लस 3.05, 2.71, 3.05 से बेसिकली कम हो करके आया है, 2.71 से कम है, 92 से कम है, so on so forth। इसका एक्सेप्शनली ज्यादा होने के पीछे देयर इज सम रीजन एंड दैट रीजन इज ये एक्चुअली इससे कम होना चाहिए था, बट ये ज्यादा होने के पीछे रीजन इज दिस कटायनिक रेडियाई। ठीक है, या दूसरे फॉर्म में हम बोले ओवर एक्सटेंसिव हाइड्रेशन। ठीक है, और वेरी हाई हाइड्रेशन एनर्जी, इनके कंपैरिजन में ये वाली वैल्यू एक्सटेंसिवली ज्यादा होती है। दिस एड्स टू इट्स टेंडेंसी टू गेट ऑक्सीडाइज्ड। ठीक है, बेसिकली जनरली सॉल्यूशन में ऑक्सीडेशन होता है और सॉल्यूशन में ही हाइड्रेशन भी होता है। ठीक है, आजू बाजू में ऑक्सीजन मॉलिक्यूल्स आएंगे, वो बाइंडिंग करेंगे एंड एनर्जी रिलीज करेंगे। Now this energy release जो हुआ that helps in transforming more and more of lithium atoms into lithium plus ions। ठीक है, so वहाँ पे एनर्जी रिलीज जो हो, एनर्जी रिलीज हुई या फिर easiness of removing electron, that obviously enhances much more। We have more activation energy, we have more energy supply because hydration energy is greater, therefore oxidation potential is higher। ठीक है, compared to that of group 2। So that is a bit of information। Now we'll start with the actual behaviors of group 1 and group 2 elements। Actual behaviors as in physical properties and details like that। So first of all we'll discuss about group 1 elements in detail and then we'll enter into group 2 elements। ठीक है, so physical properties of general physical properties of group 1 element। General physical properties of group 1 elements। silvery white, silvery white, crisp line solids. ठीक है, soft in nature or in touch, and softness increases
सर
down the group. हाँ बोलो.
ये चौबीस सर ने लिंक भेज दिया.
ठीक है, softness increases down the group.